In section 4.1, we're going to talk about our Hindu-Arabic system and early positional systems. So the first thing we need to talk about is exponential notation. So if n is a natural number, which is our counting numbers like 1, 2, 3, so on, we can write b raised to the n power, and that's the same as multiplying b n times. So b times b times b, how many ever n is. And so b to the n is read as the nth power of b, or b to the nth power. Thus, the nth power of b is defined as the product of n factors of b. We call this expression an exponential expression. And furthermore, if we raise b to the first power, that's just b. So we don't normally write a power of 1. So the first thing we want to do is evaluate the following: 10 raised to the 8th power. So let's go ahead and just expand that out. So 10 to the 8th, well, that's just 10 8 times. And when we multiply that whole thing out, we end up with 100 million. The thing that's cool with tens is the power tells you how many zeros are going to follow the 1. So 10 to the 8th means that I'm going to have 8 zeros that follow the 1. Now let's talk about our numeration system, and this is the Hindu-Arabic numeration system. So an important characteristic is that we can write the numeral for any number, large or small, using only 10 symbols, which we call digits, and that's 0 through 9. So we can write our numerals in expanded form, in which the value of the digit in each position is made clear. So for example, we can write 663 in expanded form such that we have 6 times 100 plus 6 times 10 plus 3 times 1. Well, we can rewrite 100 as 10 squared. 10 is just 10 to the first, and then 1 is not going to change. So the Hindu-Arabic numeration system is called a positional value or a place value system. The positional values in the system are based on powers of 10. So in the first rightmost spot, that's going to be your ones place. In the second spot, we have our tens place, or 10 to the first. The third spot is 10 squared, or the hundredths place, and it just keeps going up by adding 1 more power. So let's go ahead and write each of the following in expanded form. 3,407. So our 3 is in the thousandths place. So that's 3 times 1,000. Our 4 is in the hundreds place. Our 0 is in the tens place. And our 7 is in the ones place. Now let's go ahead and rewrite this with powers of 10. So we can rewrite 1,000 as 10 cubed. We can rewrite 100 as 10 squared. We can rewrite 10 as just 10 to the first. And 1 is not going to change. So the goal is just to break it apart as much as we possibly can. Let's try something a little bit more complicated. 53,525. So what place value is the first 5? The one that's in front of the 53. That's in the 10,000ths place. What about the 3 that follows it? That's the thousandths place. That second 5, that's in the hundreds place. The 2 is in the tens place. And that 5 that's to the right is in the ones place. So again, we want to make sure that we rewrite this in powers of 10. And so 10,000 is going to become 10 to the 4th because there are 4 zeros that follow that 1. We've got 3 times 10 cubed. We've got 5 times 10 squared. We've got 2 times 10 to the 1st. And we've got 5 times 1. So what we did was we broke it apart and put it in expanded form. We can also go the opposite direction. We can go from expanded and then put it into the normal Hindu Arabic numeral. So that's what we're going to do for example number 3. We're going the opposite way. So we've got 7 times 10 cubed plus 5 times 10 to the 1st plus 4 times 1. So let's just simplify each set of parentheses. Well, 10 to the 3rd, that's going to become 7 times 1,000. Then we've got 10 to the 1st, which is just 10. And 1 isn't going to change. And so that should make it a little bit easier to figure this out. So 7 times 1,000 is going to give me 7,000. 5 times 10 is 50. And 4 times 1 is 4. And so this entire thing, when I add it together, is going to give me 7,054. What about the second one? We've got 6 times 10 to the 5th plus 8 times 10 to the 1st. So again, go ahead and simplify the parentheses. That's 6 times, we've got 1 with 5 zeros, which ends up being 100,000. And then we've got 8 times 10. Well, 6 times 100,000 is going to give me 600,000. And 8 times 10 is 80. And so we end up with 600,080. Let's talk about another numeration system, the Babylonian numeration system. And so we use place values of 10, powers of 10. They use powers of 60. So their place values look like 1, 60 to the 1st, 60 squared, 60 cubed, so on and so forth. They also don't have the digits of 0 through 9. They have 2 different symbols. They have what looks like a V, which is a 1 in our system, and then they have what looks like a less than sign, which is a 10 in our system. And Babylonians left a space to distinguish the various place values in a numeral from one another. So let's go ahead and look at the first example. It looks really confusing, so let's go ahead and break this apart. Let's look at where are the different place values. So these little spaces that you see between our numbers indicate the place values. So let's just look at the first place. We have 2 V's. Well, V symbolizes a 1. And so we need to add that together. So 1 for the first V plus 1 for the second V. And that's going to be times 60, because that's their place value. And it's going to be the 60 squared position. Then we move on to the next set. We have the less than symbol and the V. Well, the less than symbol is a 10, and the V again is 1. So 10 plus 1, and that's going to be the positional value of 60 to the 1st. And our last set. we have 2 less than values and 2 V's. So our less than value is a 10 plus another 10 plus the 2 V's, which is plus 1, and that's in the first positional value. So let's go ahead and simplify each section so we can add them together. We've got 1 plus 1, so in this first one we've got 2 times 60 squared, well that's 3600. In the second one, we have 10 plus 1, which is 11, times 60 to the first, which is just 60. And in the last one, we have 10 plus 10 plus 1 plus 1, which is 22 times 1. Well, 2 times 3600 is 7200. 11 times 60 is 660, and 22 times 1 is 22. And so when I add this all together, I end up getting our number of 7,882. Let's go ahead and try the next one. So the first thing is let's see where the spaces occur. We have a space occurring right here. We have a space occurring here, and we have a space occurring here. So looking at the first one, we have 2 less than value symbols. So that's 10 plus 10. And which position is this in? 60 raised to the 3rd power. Let's move on to the next one. We have just a single V. Well, that's just 1. And so that's going to be in the 60 squared position. In the next slot, we have 2 V symbols, and that's 1 plus 1, and that's going to be in that 60 to the first positional value. And the last one, that's going to be 10 plus 10 plus 1, and then times that first positional value. So let's do some simplification. We've got 10 plus 10, which is 20. And 60 cubed is 216,000. In the next set, we've got 1 times 60 squared, which is 3,600. In the next set, we have 1 plus 1, which is going to give me 2. Times 60. And in the last set, we've got 10 plus 10 plus 1, which is going to give me 21 times 1. And so we're almost done. We've got 20 times 216,000, and that gives me 4,320,000. Plus 1 times 3,600, which is 3,600, plus 20 times 60, which is 120, and 21 times 1 is 21. And so when we add this all together, we end up getting 4,323,741. Now we're going to talk about the Mayan numeration system. And so this is probably one of the more complicated ones. We have symbols from 0 through 19, and you'll see that the same pattern is going to occur every 5. their place values are a little funky. So the first one is going to be the first place value. Then they go to 20. And then this is when it gets weird. Normally you think we go to 20 squared, 20 cubed, but no. They made it difficult. The next one is going to be 18 times 20. And then we start going up by powers of 1 on our 20. We go to 18 times 20 squared, 18 times 20 cubed, and then it would keep going to 18 times 20 to the 4th, so on and so forth. Now these numerals in the Mayan system are expressed vertically. The place value at the bottom is the 1 place value. Now let's just take a look at the symbols. We have 0 through 4, and we've got 1, 2, 3, and 4 just being the number of dots. Then we go to 5, and 5 becomes a line. To write 6, we have a line and then a dot on top. 7 is the same line with 2 dots. And we keep going in that fashion until we hit 10. 10 becomes 2 lines. 11 becomes 2 lines with a dot. So what you end up seeing is that when you hit the next set of 5 at 15, we get 3 lines. 16 becomes 3 lines and a dot. So when we hit 20, we would end up with 4 lines, and then we would add the dots on top. And that's the pattern that keeps happening. So let's go ahead and write each Mayan numeral as one of our own in the Hindu Arabic numeral system. So remember that this first one at the bottom, that's going to be the first place. The second one would be the 20th place. The next one is the 18 times 20. And the next one is going to be the 18 times 20 squared. Now we just need to match the symbols with the numbers. So let's start with the top. We have 2 lines with 4 dots. Well, 2 lines with 4 dots is the number 14. So that's going to be 14 times 18 times 20 squared. The next one is like a double circle, and that's 0. So that's like saying 0 times 18 times 20. The next one down, we have a line with 2 dots. Well, that's 7. So that's like 7 times 20. In the bottom one, we have 2 lines with 2 dots, which is 12. So we have 12 times 1. So let's go ahead and simplify this a little bit. Starting at the top, we've got 14 times, what is 18 times 20 squared? Well, that's 7,200. We've got 0 times 18 times 20, but that's just 0 times 360. We've got 7 times 20. And 12 times 1. And so 14 times 7,200, that's 100,800. 0 times 360 is 0. 7 times 20 is 140. And 12 times 1 is 12. And so now what we want to do is we want to add these all together to get our final answer. And we end up getting 100,952. And let's try the last one. So same idea. I find it easier to write the positional values first because they're a little bit funky in this one. So the first one is a 1. The next one is 20. Then we have 18 times 20. Then we've got 18 times 20 squared. And that last one becomes 18 times 20 cubed. And so starting at the top, we have two lines, which is 10. And that's 10 times 18 times 20 cubed. The next one down is three lines, and that's 15 times 18 times 20 squared. The next one down is just two dots, which is 2 times 18 times 20. Then we've got that double circle, which is 0 times 20. And the last one is just a single line, which is 5 times 1. So let's go ahead and do some simplification. We've got 10 times 18 times 20 cubed. That's 144,000. 15 times 18 times 20 squared. Well, 18 times 20 squared is 7,200. 2 times 18 times 20. Well, 18 times 20 is 360. We've got 0 times 20 and 5 times 1 left over. So let's do our last part of simplification and add them together. We've got 10 times 144,000. Well, that's going to give me 1,440,000. 15 times 7,200. That's 108,000. 2 times 360 is 720. 0 times 20 is 0, and 5 times 1 is 5. And so now we want to add it all together. And so we end up getting 1,548,725.